Alrighty guys, we're going to look at the mole-to-mole type calculation. Note this is a type of stoichiometry, which means we need to follow the steps of stoichiometry. The first one being to analyze, to find your known and unknown. 2, to determine the relationship. Once you have your known and unknown, you can look at the units of your known and unknown and determine that relationship. For mole-to-mole calculations, the relationship is the mole ratio. Step 3 is to calculate for your unknown. This is still just like with our calculations where we converted from one type of unit to the next. You take your known times your relationship as a fraction. Let's get into this for the mole-to-mole calculation. So the question reads, how many moles of potassium oxide K2O will be formed when 1.52 moles of potassium reacts with oxygen according to the following reaction? Since we're given a balanced equation, we are able to go straight into stoichiometry. If you're not given a balanced equation, you will have to find the balanced equation before you proceed to stoichiometry. This first step reminder was to find your known and unknown. I'm going to label them off to the side and to keep track of them. K for known, U for unknown. Well, your known is found where the number is in your question. But we don't want just the number, we want the unit and the type of unit that it is for. In the case of here, 1.52 moles, there's a unit, and the type of those moles, potassium. We want that information. We're going to write that next to our known, 1.52 mole, for short for moles, and potassium, the symbol of which is K. Next, we look for our unknown. Unknown is where the question word is, usually a what or a how. There's our question word, how many moles of potassium oxide K2O will be formed? So we want to know the moles of potassium oxide. So we're going to put question mark, and we want moles. We're still going, we're still keeping with the unit moles, but of a different type, potassium oxide. With our known and unknown, now we're looking for a relationship. Now you can write it out, or you can just circle it in your balanced equation, because this is going from one type of mole to another type of mole, moles of K to moles of K2O. So to get mole ratios, we always go to the balanced equation, and we circle the coefficient and the formula of both our known and unknown. In this case, we're going from K, so we're going to circle the stuff with K, to K2O. Essentially, this is saying for every 4 moles of K, you have 2 moles of K2O. And we'll turn that into a fraction when we get to step 3, our calculation. Just to keep track, I think I'll go ahead and label this as steps. Step 1, step 2. Step 3, calculating. In this case, we put our known value down first and multiply it by the relationship we found. So we're going to put down the known 1.52 moles of K. You can make this a fraction. I think I will, just because that's what I did in my notes, but you don't have to turn it into a fraction. But the multiplication process is still going to be the same. So you got your known down first, multiply it by this as a fraction. It's up to you to determine the type of fraction you want, like what you want on top and what you want on bottom. Remember that that's dependent on what your knowns unit is, because we don't want to keep moles of K. We want to get rid of it. We need to put moles of K on bottom of our fraction that we're multiplying. So we're going to take that 4 moles of K here, and that's going to be on bottom because it has the same unit as mole of K. Note, the numbers are not the same. If they were the same, our calculation would come out wrong. Very likely. We need these numbers to usually be different, and you can only, in this fraction, use the numbers that you got from the balanced equation. So the 4 moles of K go on bottom. used up that part of the relationship, so now we move this part into the fraction. The only place left is the top. Now we can cancel out moles of k. And we multiply our fractions. Note, the top of the fractions multiply the bottoms of the fractions, multiply top divided by bottom, or shorthand, you can take the top numbers multiplied and then divide by both of the numbers on bottom. So 1.52 times 2 divide by 1 divide by 4. And what you should get would be 0.76 moles of K2O. Alrighty guys, I hope this has been helpful. This is the process for mole-to-mole calculations, and if you have any questions, of course, you can come up to the front, or you can raise your hand and I will help you out. Thank you and have a nice day.